Welcome to tutorial number 420, Basic Hydrostatics. This tutorial focuses on weights in GHS. So today we're going to cover how to enter light ship weight, how to enter fixed weights, tank weights, and that includes all the different ways that you can specify the current tank level, and then how to create equilibrium using the solve command. But first, a disclaimer. This presentation is for instruction purposes only. It is not to be used in engineering for construction, and I am not a representative of Creative Systems. This is unofficial training only. If you are interested in the official training, you can contact Creative Systems at the contact information listed at the bottom of your screen. I highly recommend the official training. It's quite informative. Okay, so let's talk about light ship weight. This is specified using the GHS weight command, and this is usually used only for the light ship weight. The idea is that the light ship weight is a constant for each vessel model, but you can also use it to specify the general total ship weight. Normally when we're doing stuff in GHS, we want to track what each weight belongs to. We want to say that some of this is coming from the cargo, some is coming from the fuel, some is coming from the crew on board. But sometimes if you're just doing a quick analysis, you don't want all that. You just want weight. So you can also use the weight command for that. And the command is weight, W-E-I-G-H-T, that keyword, space, and then the number for your total light ship weight. Make sure you check what your units of weight are. That's set with the units command, and that matters before you enter the weight command. Now, normally, most of you are probably thinking, well, there is more to weight than just the actual mass. There's also the center of gravity. All of that gets wrapped up into the weight command. So the full weight command is actually 4 separate values separated by commas. You've got weight, comma, your x centroid, comma, your y centroid, and comma, your z centroid. And so that's how you enter the full weight of the vessel, which is actually the weight and the center of gravity. You don't have to do it just as absolute values, though. You can also create relative weight changes. And the way you do that is you use the star notation to specify a change to an individual weight specification. Any element you don't want to change, you just mark as star. So in this example here, I'm adding 5 feet to the vertical center of gravity. So star, 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 that's saying we're not changing the weight, not changing the LCG, not changing TCG. Star plus 0.5. So that tells GHS whatever the current VCG is, add 0.5 feet to it. Or maybe 0.5 meters. It depends on what your units are. And that works for anything like that. That could also just as easily have been typed over here to add 0.5 feet to the LCG. Okay, so that's the weight command. Now let's talk about adding fixed weights. This is used for dead weight items, things where you specifically want to track what that weight belongs to. So like I said, things like cargo, stores, crew, and by fixed weight, we actually mean physical solid objects. This is not for weight of liquids in tanks. So don't put tanks in here. That has its own separate thing that's very special. Now, the way you add a fixed weight is you use the command add. So it's ADD. In quotation marks is whatever description you want for your name item. And then just like the weight command, it's 4 values. The weight, LCG, TCG, and VCG. Longitudinal, transverse, and vertical center of gravity. Now, here's where it starts getting fun. GHS can kind of get pretty smart about the weight command. Let's say, for example, that you don't really know how much weight to add, but you know where it's going to go and you want it to be enough weight to balance out your ship. to balance out the weight of the ship, actually, so that's in equilibrium. That works really well. So what you can do is you can first set the draft and trim for your ship. That's using the draft command. And GHS does not automatically re-equalize your ship. GHS leaves it sitting there, and it recognizes that there's currently an imbalance between buoyancy and weight. And then at step 2, what you do is you add a new weight. And so give it your description, whatever you want. But instead of typing a physical number for weight, you type the keyword delta, D-E-L-T-A. And then you still specify the location for it. And what that does is GHS will actually calculate how much weight does it need to add to balance out the buoyancy of the vessel at that point. So it knows what the imbalance is, and however much that imbalance is how much weight will get added there. Now, I will warn you that that's going to balance out the weight, but not necessarily the trim. That's a separate issue. And you can also use it to balance out trim. So what you would do at that point is you would set the draft and trim. You're going to solve for weight, is the next thing you're going to do. So you'll actually equalize your draft. Or, equalize your draft basically. And then you will add another weight to equalize your trim. Again, you're adding a description. The keyword here is add, whatever description you want to be, and use the keyword RAT. That stands for Writing Arm Trim. So just like GHS tracks the imbalance of weight, it also tracks the imbalance of your writing arms, your moments. So it has a writing arm for trim and a writing arm for heel. Both of those can be balanced out. Now you'll notice both of these commands here, the delta and the RAT, both end up creating situations where balancing out one part of the ship creates an imbalance in another part. So if you balance out the RAT, the trim, now you've got a weight imbalance, and so now you've got to basically iterate this a little bit, go back and forth 3 or 4 times, cycling between these 2 commands to get it perfectly balanced. So it's not a magic bullet, but it certainly helps save you some time from guessing it randomly. Okay, now remember how I mentioned that tanks are a special thing. Tanks have their own special command. Let's talk about that special command. The command for tanks is load. Now, this assumes that you have already defined all of your tank parts in GHS. And the way the load command works is the load command specifies the level of liquids in a tank. And there's a whole lot of different ways that you specify it. So at the first part, all you have to know is the command load, that's the keyword, L-O-A-D, parentheses, and then in parentheses you type the part name of whatever tank you're trying to load at the moment. And that's the GHS part name for the tank. Now, there's a whole bunch of different ways you can do that. You can specify just one part name. You can separate part names with commas to specify multiple ones at once. You can also use the wild character, the star character, and it will specify all part names that match that first half. And so that's how you select your parts. Now you have your load specification. There are many different options for how to specify the load of a tank. Here are just some of the most common ones. So the first option is just a straight fraction. So fraction 0.50. So if I said here, if I said load WBT1.P 0.50, what that's saying is our WBT1.P should be filled up until half of its volume is full. Half of its volume. Okay. You can also specify it as a specific weight. That's with the keyword WE:, and then whatever weight you want in there. That's weight in whatever your current units are. So this is why GHS needs to know what the density is of liquids in your tank, because it actually does all of this conversion between weight and volume. Speaking of volume, if you happen to know exactly what the volume is, you can also specify a tank weight or a tank load that way, is the VO keyword. Now, here's a catch. Here's a catch. You only specify volume in cubic units. So if you have your unit specified in GHS for meters, for example, then this 1432 is 1,432 cubic meters. So you don't get just, with the load command, you don't get to do liters or gallons or barrels or anything like that. It's only cubic units. So that's going to be cubic meters, cubic feet, so on. Now, let's also match up with what the operator has. Remember, the operators have sounding tubes on these ships that they're checking with a tape measure, basically. It's actually a sounding tape. It's a specialized tape measure. So you can type it in that way, SO, and that stands for sounding. And then you're specifying the actual distance on the tube. So this is the distance that they will read off of their sounding tape. And what a sounding is the distance from the bottom of the tank to the level surface, or to the surface of the liquid in the tank. Now there's another way to do that. Still use the sounding tube, and you can specify an ullage. An ullage is the distance from the surface of the liquid to the top of the tank. So sounding is going from bottom up, ullage is going from top down. And there's preferences between everybody about who likes to do which one or the other, which is why GHS lets you type in both. Now, both of these require that you've defined a sounding tube ahead of time. That has to be part of your part properties. Okay, so there were lots of different ways to specify loads for tanks. Guess what? There's a few extra ones. You can actually use the load command to balance the ship. And this is actually pretty common. That's what a lot of our ballast tanks are used for, is to balance out the ship. For example, balancing out the trim. So the way that works, there are 3 keywords, and it works just like the add command, except you don't need to specify a location anymore. You just specify the tanks to include. So it's still using load command, whatever tanks you're going to fiddle with in there, and then for your load specification, you can use one of these 3 keywords. Delta will balance out the weight, RAT balances out the trim, and RAH balances out the heel. Now here's a little bit of a footnote about using these commands to auto-solve for tank fill levels in GHS. Now, GHS does not auto-solve tank levels. It's not smart enough to know the correct way. And what I mean by that is, if you've got a tank on starboard that's too full and a tank on port that's too light, then you might naturally think, oh, okay, we'll take a little bit of load out of the starboard tank and add it into the port tank. GHS is not smart enough to do that. And there's a very good reason for that, actually. Is when you start talking about stability for the ship, just having the computer dumb solve tanks, it's very easy for the computer to create all the tanks partially full, and you're going to rapidly end up with large amounts of free surface moment from those tanks. And it's very possible for the computer to just dumbly create a tank loading situation that is unstable, that will actually cause the ship to be in a dangerous situation. And that's why GHS does not do auto-solving for the tank loads, is because the computer isn't smart enough to do those checks for safety. So you still have to do that all yourself. Now, what does happen, if you specify multiple tanks for GHS to load, it will take however much weight it needs to produce, divide it evenly across all of the tanks you've specified, and add that into each one of those tanks. Okay, next, how do we balance out the weight? How do we balance out the ship? So far what I've been talking about ways that if your ship is too far in the water, how do you change the weight of the ship to balance it out? Well, usually we're going the other way around, where the weight of the ship is something that we know, and we want to know how far it is in the water. We want to know its draft. How do you do all of that? You issue a solve command to get the command to solve for equilibrium, or to get the ship to solve for equilibrium. And this is actually a really important thing, is GHS does not automatically solve for equilibrium. It does not automatically do it. It's quite happy to leave you with an imbalance of weight or trim or heel. And you have to manually tell it to balance out. Now, for anybody that's used some of the more advanced features of GHS, like Load Editor, in that case, it does have a few auto-solve features, but when you're talking command line only, it does not automatically solve. And it's better for you to assume that it doesn't automatically solve, because there's no harm in issuing extra manual solve commands. And if you really want to be a powered GHS user, you've got to get that in your head so you're comfortable working from the command line. Okay, so let's talk about an example of different types of imbalance. So you can see here, look at this output window. What I've done is I have created an imbalance in weight. And this is the first thing right here. So you can actually see them at the bottom. And so we've got the weight and the depth, and it's actually said that right now there is 153 tons of too much weight. Now notice that's probably because, or excuse me, I have that wrong. There's negative 153 tons of too much weight. So that's saying that there is more buoyancy than there is weight, which is quite believable since there's no weight right now. This ship has a weight of 0. So what do? We issue the solve weight command. So solve keyword weight. Now notice, okay, it's balanced out the weight. It's added that weight on. And now, though, it said, well, where is that weight? Well, it just automatically entered it at the origin. So at an LCG of 0 and at a TCG of 0. And now it's saying, well, now your trim and your heel are imbalanced. See right here, your writing arm in trim is 16.8 meter or 16.8 feet, and your writing arm in heel is 1.36 degrees. So now those are imbalanced. So how do we solve those? Well, there's lots of different ways to solve all of that. And it's a question, do you solve the ship or do you solve the weights? But you'll notice all of these, what we're talking about is with the GHS command solve. And the way that the command works is you type the solve command, SOLV, and then you specify a series of parameters separated by commas. You can do pretty much as many as you want, though in reality you usually don't ever need more than 3 parameters. And GHS will solve those. If you don't specify it, GHS does not solve it. Kind of. The default operation, if you just type solve with no parameters at all, SOLV, then this is what GHS will assume by default. It assumes that you want to solve for draft, trim, and heel. So you don't change any of the weights on the ship, you change its waterplane orientation. So what kind of parameters can you solve for to change the orientation of the vessel? Well, you can do a solve for draft. That's pretty nice because that changes the vertical draft in the water, but it does not change the trim. And then you can do a solve for trim, which changes the trim, and a solve for heel, which changes the heel. And these are all the keywords that you know. So draft, trim, heel. So let's show you an example of how we solve for orientation. So first off, you can see here right now we've got a depth of 5 meters excuse me, 5 feet, and we have an excess of weight right now. So I issue the solve command, and I've chosen to solve for weight. This is an option. And so now, if you look up here on the status, suddenly my weight excess has gone away, but now I have an imbalance in my orientation. So now I issue a solve command for trim only, and now look, my trim has changed, and I'm back in balance now, but still out of balance in heel. So one more time, I issue a command for solve heel, and now I'm back in heel, but look, changing the heel actually put me a little bit out in trim as well. So what I can do is I can issue both commands at the same time, solve trim comma heel. And what it does then is the solve command actually iterates between the two until they're both in balance. And what I really want you to notice for all of these was see how it's controllable. You get to specify exactly which parts GHS brings into balance. So that's a really nice bit of control. That lets you play a lot of what-if scenarios. That lets you adjust only certain parts. It's very powerful. Now, you may have seen me using them already, so that there are several weight parameters that you can also solve for. So you don't want to change the orientation, you want to change the weight. You can use the solve weight command, which will change the light ship weight of the ship. Now that's the key part there, is it changes the light ship weight, the weight that you've set with your weight command. So if you've added any dead weights, those don't change. You can also use the solve for LCG, changes the center of gravity. Again, it's the light ship weight of the center of gravity. And TCG, same thing, changes the light ship weight center of gravity. So here's an example of that. Again, notice we've got a weight imbalance. So I issue the solve weight command, and I've updated my status now. Now notice my weight is in balance. My light ship, now I have a negative light ship. And that's one of the things I want to show you. So here's the interesting quirk. It's saying that I have too much weight here. I've got 400 tons of dead weight, and that's too much. So I need to actually get less weight. So I issued my solve command, and it added that weight to the light ship. And so it's actually saying now that I have a negative light ship weight, which is not really realistic unless I'm tying giant helium balloons to my ship. Not likely. So I want you to notice this, that you can actually create nonsensical solutions with the solve command. But let's go forward for the moment. Next, I'm going to solve for LCG. So now you can see my LCG is in balance. And if we look here at the light ship, it's moved forward. So that's quite normal. And if we do it one more time, this time solving for TCG, again, now I'm back in balance, and you can see my TCG has moved as well. Now, notice that it's only adjusting these positions here on my light ship weight. So that's another key part here, is if your light ship weight is very, very small compared to the rest of your dead weights, it's going to put these centers of gravity really far away, probably physically off of the location of your ship. Mathematically, GHS has no problem with that. Practically speaking, as the user, you should be wondering about it. Okay, that was everything we wanted to cover in this homework. It's time, or excuse me, in this tutorial. It's time for you to practice yourself. So I want you to manually create the following cases, and I want you to solve them one step at a time. You're going to use the FV vessel. That's a built-in vessel that GHS has, meant for practicing stuff like this. And the key part here is I want you to first create the weight changes, and then solve for draft, trim, and heel one at a time. Do them one at a time to make sure you know how to control solving each one at a time. So the first case I want you to create is the light ship case. So I want you to add a weight of 250 tons, and add an LCG of 2 foot aft, TCG of 0, and VCG of 5 feet. Now that's light ship. So to add the light ship weight, you should be using the weight command. And then once you've done that, you've added your light ship weight, you've solved for draft, solved for trim, and solved for heel as separate commands. Then we're going to do the departure condition. And what I want you to do for the departure condition is take that light ship weight and add a new dead weight item. So you're going to use the add command, which is going to use the stores. And there's your weight location for the stores, 50 long tons at 15 feet forward, 50 feet starboard, and 10 feet up. And again, do a solve for that. So draft, trim, and heel. And then finally, I want you to do another load case that is the full fish hold. This is an FV. It's a fishing vessel, and it has a fish hold in it. So I want you to load the tank, hold 2.c, that's the name of the tank, and I want you to load it with a weight of 20 tons. Now you shouldn't have to do any math. You should be able to actually just type in WE for weight, colon, 20 LT. Or don't include the LT, just 20. And GHS will work that out. Then I want you to set a draft of your ship at the LCF of 10 meters. I want you to give the ship a heel of 5 degrees to port, and that's going to create an imbalance in weight. So now what I would like you to do is load up hold 1.c to balance out that weight. So you're going to have to use one of those GHS keywords, and that will load up hold 1. But that only balanced out the weight, not the moments. So the last thing I would like you to do is add a fixed weight at the location of 0, 10 port, and 15. And I want you to add that weight, have GHS solve for the weight to balance out the trim moment. And that, well actually, the trim moment and the heel moment as well. Now when you do that, here with the tank load and the fixed weight, you're going to find out that those two are going to start fighting each other. Your trim is not going to balance out your weight is not going to balance out your trim, and you're going to have to manually issue some solve commands there in the middle as well to solve for draft. So you're going to probably get GHS telling you a few times that it's not happy. And that's something where you're going to have to work it out, and that's intentional, because I want you to work out exactly what sequence of commands you have to use those keywords. Okay, well, thank you very much for watching. I hope you found it educational. You can find the homework along with solutions and other videos on dmsonline.us. Thanks very much.
Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button, and I will make more videos for you.